Welcome to this lab on LangGraph tutorial, complete guide to building AI workflows. LangGraph is a powerful Python library that simplifies creating, managing, and visualizing complex AI workflows. Built on the popular LangChain framework, LangGraph makes it straightforward to handle stateful workflows, conditional logic, loops, and multi-step interactions. Think of LangGraph as a visual flowchart builder for AI logic. LangGraph helps you see how data moves through your application, making it simple to manage and debug. Key characteristics of LangGraph. Visualize complex AI workflows as intuitive graphs. Stateful, maintain state information easily across multiple workflow steps. Conditional, create flexible workflows with conditional branching and loops. User-friendly, build sophisticated applications without messy, nested logic. Let's dive deeper and discover how LangGraph works. Installing LangGraph locally. Getting started with LangGraph is straightforward. All you need to do to install LangGraph is use pip workflows as graphs, where each function, called a {node yen, performs a task and passes state to the next. This example walks you through building a simple workflow that prints a welcome message and a question using LangGraph. Here is the step-by-step breakdown of the process. Step 1. Defining the state and node functions. First, we need to define the state of our graph. The state is a Python object, typically a dictionary, that gets passed between nodes. We must define its structure upfront using type dict. Each node is a Python function that accepts the state object and returns a dictionary with the modifications to that state. In your main.py, start by writing the following code. Here's what each part does. 1. Graph state defines that our state dictionary will contain string keys named message and question. 2. Welcome state adds a welcome message to the state. 3. Question state adds a follow-up message to the state. 4. Display state retrieves both and prints them to the console. Step 2. Initializing the graph and adding nodes. Now, we create a state graph instance, passing our graph state definition to its constructor. Then, we add our functions as named nodes. Each node is given a string label, example {welcome yen, and the corresponding function. Step 3. Defining the execution order with edges. Use setEntryPoint to define the first node to run and add edge to specify the flow between nodes. Here's the explanation for each line. 1. The workflow will start at the welcome node. 2. After welcome finishes, control moves to question. 3. After question, control moves to display. 4. End is a special keyword that signals the completion of the workflow. Step 4. Compile and run the workflow. Finally, compile the graph into a runnable application and invoke it with an initial empty state. This will trigger the full sequence, and you will see the expected output. And just like that, you've created a simple, clear, and functional workflow. How to manage complex workflows. LangGraph shines brightest when handling conditional logic. You can easily create branches in your workflow that execute based on the current state. Let's imagine this scenario: your application needs to respond differently based on a user's query. First, we define the state and the functions. The key here is a node, check query, that returns a decision that LangGraph can use to route to the next step. Next, we set up the conditional workflow in a single, runnable script. When you run this code, the check query node will see the word {pricing yen in the input and update the state's next value to pricing. The add conditional edges logic will then route the workflow to the pricing info node. LangGraph simplifies complex branching logic into a clean and natural workflow. Let's explore why we should consider using LangGraph. Why consider using LangGraph? While LangChain helps you build AI chains, LangGraph takes workflow management to another level by visualizing how each part of your AI logic connects, managing complex branching and decision-making tasks effortlessly, handling state and memory so your AI remembers essential information throughout the workflow. This means you spend less time debugging logic and more time enhancing your AI's capabilities. Let's look at the key components of LangGraph next. Key components of LangGraph. LangGraph operates using these simple yet powerful building blocks. Nodes, individual actions or tasks your AI performs, such as asking a question or processing input. Edges, the connections between nodes that define your workflow sequence and logic. States, the data retained between steps, ensuring your AI remembers context. You must define the schema for this state. Conditional logic, decision-making branches based on real-time conditions or user input. Together, these components form dynamic, interactive, and intelligent workflows. Real-world applications of LangGraph. LangGraph isn't just theoretical. It's powering real-world use cases like AI assistants, intelligent virtual assistants with conversational memory. Research agents, agents that search, summarize, and remember data. Customer support, smart agents that resolve queries intelligently and autonomously. LangGraph simplifies managing these complex tasks, making AI practical and accessible. Conclusion. In this guide, we explored how to use LangGraph to easily build, visualize, and manage complex AI workflows from simple setups and conditional branching to complete multi-step research agents. We covered installing dependencies, defining states, setting up nodes, and structuring your workflows using LangGraph's graph-based approach. Additionally, we discussed practical, real-world applications where LangGraph shines, such as virtual assistants, intelligent research agents, and smart customer support bots, demonstrating how LangGraph simplifies complex AI tasks. Frequently asked questions. 1. What is LangGraph used for? LangGraph simplifies building and managing complex, stateful AI workflows, representing them as clear, visual graphs. 2. How do you visualize workflows in LangGraph? LangGraph has built-in visualization features that can generate graphical representations of your workflows, example as PNG images, simplifying debugging and management. 3. What is the difference between LangGraph and LangChain? LangChain provides the core components, LLMs, tools, etc., while LangGraph is a library for orchestrating these components into robust, agent-like loops and graphs with cycles and state. 4. Is LangGraph suitable for production use? Absolutely. LangGraph's clarity, scalability, and maintainability make it ideal for building and deploying complex AI applications in production environments. 5. What is the purpose of state in LangGraph? State allows the workflow to retain essential information across different steps. It's the memory of your graph, ensuring continuity and context for long-running tasks. 6. What is the purpose of typedict in LangGraph? Using typedict to define the state schema enforces a clear data structure, enhancing code readability, enabling static analysis, and reducing potential errors by ensuring nodes access and modify the state consistently.